Okay guys, how are you? Today we're going to look at RIP network configuration. Basically in this video we're going to look at what is a RIP network and how to configure a RIP network. Is it just a simple information or simple configuration in a real Cisco environment or inside the exam? Okay, first of all we need to know what is RIP. It's not what the meaning of the RIP. RIP is a routing information protocol. It's a widely used protocol in all the environment. What I mean by all the environment? RIP protocols not only specified can be used under Cisco, it's still able to use in other vendor too. Example Huawei, example HP. But in this video we're going to look at the RIP routing information protocol and how to configure in Cisco router. RIP routing is a managing router information within a self-contained network such as LAN or corporate LAN or interconnected group LAN. Usually what is a RIP routing is just going to send information across to the network to a different router that located from different geographical location. What I mean by different geographical location? Example, one of your router was located in Kuala Lumpur, another router was located in JB. How this information going to pass across the internet and reach to that particular place, I mean in JB, with the correct information. So how the protocol of routing you're going to use is one of example we're going to do is a RIP. RIP is classified by the Internet Engineering Task Force, is IETF, as one of several internal gateway protocol team. Using RIP, a gateway host, or we call it with a router, it send an entire routing table to its closest neighbor host for every 30 seconds. What mean by this? Inside the RIP network, I mean a RIP network protocol, they're having a routing table inside the RIP network. What the routing table will do, he will learn is a routing protocol and will pass the information to his neighbor. His neighbor means next router beside him about the information. In other words, you're going to gossip or we're going to share. Is having the same meaning to a next router every 30 seconds. That means every 30 seconds you're going to keep sending the routing information. Even the particular router already learned the routing information. The neighbor host in turn will pass the information on the next neighbor. What I mean by that? Let's say we having a three type of router: router 1, router 2, router 3. Router 1 will send is a routing table to router 2. Router 2 will learn and update his routing table and will send his router 2 routing table that he learned from router 1 and his own router table and send to the router 3. Is how is a routing table was being passed through from one router to another router. RIP network also use a hop count as a way to determine the network distance. What I mean by network distance? Other protocol use a more algorithm that include the timing as well, because we then look at the RIP using a hop count to send a routing table to another router. But when look at other routing protocols such as OSPF, they're using a different type. They're never using a hop count. And for that particular information, we're going to look at the OSPF video. Okay, each host with the router in the network use the routing table information to determine the next host to route a packet for a specified destination. RIP is considered an effective solution for small homogeneous network. What I mean by that? RIP is considerable is only can using for the small environment or less than 2 or 5, or maybe it's a 20 or 30 piece, 30 router. Why is not recommended for use for high, very large environment? Because you need to understand, as what I mean earlier, RIP is going to send is a routing information every 30 seconds to is a neighbor or next router that sit beside the router, and it could cause the high traffic. What I mean by high traffic? Let's imagine every 30 seconds you're going to keep telling the same information. Even he already update the information. So during this during you keep repeating this information, it will cause you high traffic. That's why we not recommended for using for large. As what we can see is for large or more complicated network, RIP transmission for entire routing table every 30 seconds may put a heavy amount of extra traffic in the network. This is the reason why we not recommend using a RIP network topology inside a router for large network. Even the RIP network configuration is very easy. The another thing you need to understand is there are major alternative way you can use for the large network. You can using as a OSPF. We're going to discuss about OSPF in the next video, but at the moment we're going to look at the RIP network only. The important things, the highlight things over here, you need to know what is AD. AD is called a administrative distance. Once you already done the routing configuration, when you done a show run or show IP route, you must see the administrative distance is 120. It's usually as a famous question you will ask in a Cisco. Okay guys, how we already know what is a RIP network. Now we're going to look at how to configure a RIP network. Okay, let's say I having three type of route. Three router here, 1, 2, and 3. Okay, I'm going to magnify it. Okay, I think it's able, you can see clearly. Okay, first of all, when you already drag a router from here to here, you just double click the router, you can see having a off button. Okay, first of all, this is a Cisco packet tracer. For a beginner who are never see before this, Cisco packet tracer is a free software to learn how to do a configuration before you implement in real life. Okay, we click on the first router. Before we start our router, we need just switch off the router and we're going to pull out the interface, two serial interface, and fill up to the empty slot and on back the router. Okay, we're going to do the similar thing to the second router and third router. I already already put as 1, 2, 3, 4. Same go to here, 1, 2, 3, 4, and on. All the router is on. Now, how are you going to configure? First of all, you can see we having a connection. You click on the connection button, you can see having a type of connection we're going to use. Okay, just for information, you need to put a connection from router to router. You can use as a serial DCE. You connect from serial all 0 to the all 0. Pull out another serial cable, put at 0/0, 1 at another 0/0/01. Okay, you can see we having interface here. We having interface here. You already put here. Now what next? The next thing is we're going to pull out a switch. 1, 2, 3. Once already pull out switch, we're going to put as a straight cable. Let's say I have straight cable only we use for the different group of device. Let's say we having a same device, like say router or switch to switch, we using a cross cable. At the moment we using straight cable because this is a router group, this is a switch group. So there are two different groups. So two different group we can using a straight cable. Okay, now already connected. Now I'm going to pull out one PC here. I'm going to pull out one PC here. I'm going to pull out one PC here. Once already pull out, see I'm still using a straight cable because switch and computer is two different groups. Okay, once you already pull out all the information. Now I'm going to label it. I'm going to differentiate the network. I'm going to put class A 10.0.0.0 slash subnet mask. Sorry, the mask is 8. I'm going to put here the second network 11.0.0.0. mask is 8. It's a class A. Class A. I'm going to put another IP address 192.168.1.150. Okay, this is the gateway for the router 1. Now I'm going to create gateway for the router 2. 192.168.2.150. Let me copy this first. I already create for the second router gateway. Now I'm going to create for the third router, but now it's going to be 3.150. Okay, all this IP address gateway, this is called gateway IP address, you're going to see as the this gigabyte internet. Similar goes to here, similar goes to here. Now what will be the IP address for the PC? IP address for the PC, you need to type 192 according to, must be under the same subnet. Okay, and here I'm going to key in 192.168.1.1. here I'm going to click at 192.168.2.1. is it correct? Yeah, it's correct. 192.168.3.1 already created. Now I'm going to put this IP address inside desktop. Now what is my default gateway? My default gateway will be 192.168.1.150. 192.168.1.150. We're going to do the similar thing to the second router. Now I'm going to use 2.1, same here, 2.150. This is my gateway. Is it correct? Yeah, it's correct. I cancel. Okay, save, ready. Open back, double click. Now it's a 3.1, 255, 3.150. Enter. Click. Now we already assigned IP address. You can see it's already now is connected. Now what you can see here, the red color dot here is considered this particular port was not up. So what we're going to do, we're going to up the interface. We can see here we're having gigabyte interface, we're having a serial interface, we're having gigabyte interface, we're having a 2 serial interface, 1 gigabyte internet, 2 serial interface, and here you can see we're having a serial and a timer. For this particular interface, we're going to set a clock rate and bandwidth. Okay, similar goes to here. So just look one by one. I'm going to click on the first router. Okay, I open CLI. Okay, these are the information you're going to see in your real environment. Let's see, open terminal. You're going to see this. Okay, what the first step? They ask you continue with the configuration dialog. I'm going to click no. I'm going to configure as manual. Okay, now I'm going to create. I'm going to enable. EN is the enable mode. Once I click enable, I'm going to rename this router. I'm going to click. Before that, I'm going to config terminal. I'm going to create its name, host name. I'm going to click R1. See, the earlier part is router. Now every once click, it's going to become R1. Now what is my second step? My second step is I'm going to configure the interface. Okay, before I configure, I should know the interface. are going to configure the gigabyte 0/0, and with the IP address 1.150. I'm going to configure config t oh sorry, it's already under global configure mode. So what I'm going to do, I'm going to configure interface gigabyte 0/0. Then I'm going to click IP address 192.168.1.150, following by its mask 255.255.255.0, and click enter. Once you click enter, I'm going to click no shut down. Okay, you see just now my link was down, now it's already been up. You can see here the green color dot. Okay, now I'm not going to stop here. I'm going to configure my serial interface. I'm going to exit. I'm going to configure interface serial. What's my serial ID is a 000. I mean will be my serial ID is will be 0/0/0. I'm going to add IP add 10.0.0.1. the mask will be 255.0.0.0 because it's a class A. I'm going to click enter. I'm going to click no shut. Once you click no shut, I'm going to key in because I'm going to set up a clock rate. You see, having a clock symbol here to this particular interface. This particular interface, I need to set a clock rate. Clock rate 64,000. Enter. I'm going to click bandwidth 64. Then I'm going to click exit. Okay, once you already exit, you can see here the interface is still down. Why the interface is still down? Because we never configured another part of the router for the interface. Once I configure this particular router, automatically interface will be up. So let's have a look to the second router. I'm going to click enable config t interface. So before that I need to create a name, host name. I'm going to create R2. Then I'm going to interface gigabyte internet all 0/0. I'm going to click IP at 192.168.2.150 255.255.255.0. Then I'm going to click up down, up this part. I'm going to click no shutdown, enter. Automatically my link was up. Now I'm going to configure. See here, I'm going to configure two interfaces. One interface without the clock, one interface with the clock. So first I'm going to configure on the left hand side. Because I'm going to exit, I'm going to config mode. It's called a config mode. I'm going to click interface serial 0/0/0, enter. IP add 10.0.0.2, mask is 255.0.0.0, enter. No shut. Okay, finish. Okay, you can see at this particular interface serial for the second router, this particular don't have a clock. Because of that, we're not going to set the clock rate. We're only going to set the clock rate for this particular interface. Now you can see the interface already up here. Now I'm going to configure the second. Sorry, this is a first interface configure. Second interface now is third interface. They're having a clock. Now the interface is SE0/0/1, and the IP address will be 11.0.0.0.1 is a class A. I'm going to exit interface. 0/0/1 IP at 11.0.0.1 255.0.0.0. I click add. Now I'm going to do no shut. Once you click the no shutdown, I'm going to click clock rate 64,000, bandwidth will be 64, and exit. Finish. Now already finished. I'm going to my third router. Going to do the same things here. Enable host. I'm going to config T host name R3. I'm going to configure interface gigabyte internet 0/0. I'm going to put IP at over here is 192.168.3.150. mask 255.255.255.0. no shut, exit. Enable back, config T, interface, serial. Now the serial is 0/01. 0/0/01. Enter IP at 11.0.0.2 255.0.0.0. Now I'm going to click no shut. Finish. I'm going to exit. Okay. Already finished configure the router. Okay, now you can see all my port was up. Okay, now what I'm going to do, I'm going to, using this router, I'm going to do a ping, I mean a test. Is it possible my router from here can ping my second router? What I'm going to do, I'm going to exit. I'm going to ping 10.0.0.2. where 10.0.0, this interface using 10.0.0.2, this interface using 10.0.0.1. you can see I sending 5 data and get a success rate is 100%. 5/5 was received. Okay, now what will happen? Let's say I'm going to ping 11, network 11 in another network .0.0.2. you can see here the request will be failed. This folder is loading. You can see the success rate is 0%. Why it's happened like that? Just simple. We at the moment we just configure the interface only. We never configure the topology. The topology mean is what type of routing topology that we going to use to configure to make sure this particular fella can bring this information across this network, across this network. Okay, first of all I'm going to click this. Now I'm going to configure a router. I mean it's going to configure a RIP topology. I'm going to first enable mode. When I magnify it, okay, enable. I'm going to click config terminal. Now I'm going to router RIP. Now I'm going to put network. Okay, the network will be what network is belong to this particular router. These are one network and these are the one network. That means network 192.168.1.0 and 10.0.0.0. So I'm going to put here 192.168.1.0. 1.0 and click enter. Now I'm going to put network 10.0.0.0, click enter, then automatically I click exit, finish. Now I'm going to cancel it. I'm going to open my second router. Before going to second router, you can see we are having a 1 network, 2 network, 3 network. So 192.168.2.0 and network 10 and network 11. We're going to configure it. I'm going to global command. I'm going to enable. I'm going to config T. Then I'm going to go router RIP. I'm going to click network 192.168.2.0. Then the second network 10.0.0.0.0. Then the second network, the third network will be 11. Now I'm going to click exit, enter. Going to close this and going to close my third router. Third router having a 2 network, 3.0 and network 11. I'm going to enable config T router RIP network 192.168.3.0 11.0.0.0, enter, exit, finish. Now what will happen? Now what we're going to do, we double click on this. I'm going to exit back. I'm going to see my routing protocol. I'm going to click show IP route. You can see this is my IP route and my RIP network is R. See, my R was configured here. Network 11. This is the administrative distance I mean earlier in that slide. See, my network 11. This my network 11 is entering to the network 10 via the network 10 because it's now is learning its own part how it's going to travel. Now I can ping successful. Just have a test. See here. I see success rate is 100%. Okay, so what we're going to do, we're going to double text, we're going to run, we're going to ping 192. We're going to ping the PC in the third router 168.3.1. You can see we are having a replay. We're going to ping again. Now I can send information across the network to the third router using a RIP topology. We also can using this packet. We can put here. You can see here successful. You can put here. Successful. Either we also can check on our routing table. Can auto capture. It will show you. You can see here now my information was traveled across the network to each of the PC. This is how information was being transferred. Okay guys, this is called as a routing RIP protocol. Okay, now I'm going to show you a timer. I mean, it's a topology. How is the routing table was been updated? Okay, let's imagine I having a 3 router 1, router 2, router 3. These are Hyderabad, these are Chennai, these are Bangalore. They mean 3 router in 3 different states. Okay, now I have it's called a routing table. How the information going to send from this router to this router, This is the routing table already inside this particular router. Similar going to the second router, third router. Have a look. It's the same as what we configured earlier. Now this fella going to send the information across to the network. The information, see, I told you these are the information 1, 2, 3. These are the origin information. Now what will happen, you can see this fella information is going to send across to this network. 30 seconds, you can see the number here. Now the information routing table will update here. Another one is updated. Now this fella going to take 30 seconds, going to send this particular network to here. Wow, you can see here, similar going to here. Now he going to send his information here. These are the concept how a routing table inside the RIP topology going to send information every 30 seconds. Okay guys, these are the end of the video. This is called a RIP topology network. How is the configuration and what is the RIP topology? Okay, in the next video we're going to look about the OSPF. Okay, thank you very much for watching this video. Bye bye.